All right, so we are now looking to evaluate the limit of the trigonometric function, the limit as t approaches 0 of sine of 5t over 4t. Again, first thing I always try is direct substitution. So when I do that, I get sine of 5 times 0, which is 0, and then 4 times 0, which sine of 0, if you remember, is 0, and 4 times 0 is 0. So we get this indeterminate form. Sometimes in a calc class, people will see this problem and just avoid it. And that's because they see that trigonometry, and that trigonometry just, they're not strong in trig. Maybe they really haven't had a trig background. For whatever reason, they avoid this problem altogether because they see that trigonometry. I encourage you not to do that. And if where you get stuck is just sine of 0, there's some options for you. If you have a scientific calculator, it can evaluate, many of them can evaluate sine of 0, but also on exams in my class, you're allowed to use the unit circle. And so if you need an example of how to use the unit circle to evaluate different trig functions, always just see me or something like that. Now, in this section, when the squeeze theorem was addressed, there was a specific limit that was given, which is the limit as theta approaches 0 of sine of theta over theta. And we were told, based on the squeeze theorem, that limit equals 1. We're going to use that to evaluate this limit. Okay, so one of the first things I look at is I might be tempted right away to just say, hey, this equals 1. When I really look at it, though, I have sine of 5t is within the sine function, and then I have 4t. 5t and 4t are not equivalent expressions. And notice in the theorem for this limit, it does say that what you input into the sine function and what you have in the denominator need to be equivalent. So we can't just say that this equals 1, although that's a temptation that I see a lot of students wanting to do when evaluating this problem. Okay. So what I am going to do, though, is I'm first just going to factor out that 4 from the denominator. So if I factor out a 1/4, that's really just a constant. And I have the limit as t goes to 0 of sine of 5t over t. Now, again, we still don't have the same input into the sine function as what we have in the denominator. But I can use my well-chosen 1 technique to get a 5t in the denominator. So I'm going to actually multiply numerator and denominator by 5. And so 5 over 5 is 1. We're just changing the way that it looks. In the numerator, I'm going to factor that out. I'm not even going to bring it within what I'm taking the limit of. So I'm going to bring that 5 out front. I have then a 5 over 4 times the limit as t goes to 0. I have a sine of 5t, and then the other 5, I'm going to leave that in the denominator. So then I have sine of 5t over 5t. And you might recognize then that this expression and this expression are both the same. So this limit as a whole is going to equal, based on that theorem, this is going to approach 1. So what we end up with is this is going to be 5/4. The limit as t goes to 0 of sine of 5t over 5t is going to be 1. So we have 5/4 times 1, which gives me a 5/4. All right, so the limit as t goes to 0 of sine of 5t over 4t is 5/4.